Hi everyone. Today's class we are going to give introduction of trigonometry, which is a vast topic. So, we will continue the same till the end of this month, and here this topic we start from the basic level and we will go till advanced level also. Now, in general mathematics you feel a very tough subject, that is only your feeling, but if you think in that way then it will be tough, but if you think you can do it. While solving a problem, in the middle if you stuck up it, immediately we want to give up. But whenever you see any problem while solving it, in the middle a problem seems to be very small, but the smallest thing also matters in mathematics, because the whole procedure leads to the complete solution, and the last step, especially in JEE mains level, advanced level, the last step is very important. We start problem from the beginning. In the middle, suppose a small change in plus minus symbol if you observe, the total problem will spoil and finally your answer will go wrong. That is the reason we have to pay complete attention from the beginning till the end of the problem. That is why in mathematics, to solve problems with complete confidence, we require a rigorous practice. And that practice is very important. The formula just to solve mathematical problems is, number 1 it is practice, number 2 it is practice, number 3 it is practice. That is why we started here the teaching of mathematics in advance, so that in houses also students just they can observe by sitting here before your TVs or channels, just taking one pen and notebook, and thereby you just copy here whatever we are teaching, listen carefully, and immediately you just turn up your practice towards good problems and all, then definitely you will be seeing very good fruits in future. Now let us start trigonometry. What is the meaning of trigonometry? Trigonometry, the meaning actually it is, tri means actually it is three, and go now here it is coming from other languages. So, it is as a whole we can say 3 angles measurement. So, 3 angles measurement we are going to see now, and first of all we consider this one using right angle triangles. And here this topic actually developed by Indian mathematician Aryabhatta, and next one is Greek and Russian, even Arabic also. So, while completing this topic here trigonometry, and here you have to observe the efforts of all these mathematicians. Actually, what is the use of trigonometry? The use of trigonometry is especially land surveying, civil engineering, oceanography, etc. In many ways you can observe the importance of trigonometry. Now let us start here trigonometry, and before we start trigonometry, what are the basic concepts which we have to go for JEE level, as mains level as well as advanced level. The topics here they are, first one is trigonometric ratios, and next one is ratios, here you can say identities also, trigonometric ratios as well as identities also. And next second one is compound angles, third one is multiple and submultiple angles, this is third one. Fourth one is transformations, and next fifth one it is extreme values, graphs, periodicity of trigonometric functions. So, these are main thing which you have to observe in total trigonometry, and this we call it as just trigonometry. And in this trigonometry, while going through each and every topic here you can enjoy, because these topics are further not only in mathematics you see, in physics while solving problems, and in many concepts also you can observe all these concepts. That is why this is important, that is why we have to start in the beginning of our that is 11th standard, and many of the students know very well even in their 10th class also. So, now let us start with trigonometric ratios. But whenever you observe the syllabus in JEE mains level and advanced level, they just give trigonometry Now trigonometry means you have to understand it is up to transformations including these topics also. So now we are going to start here with the trigonometric ratios. So what about these trigonometric ratios? Let's start with some right angle triangles. I am drawing here right angle triangles. Observe carefully how I am drawing all these right angle triangles. So these are different right angle triangles I have taken, and in these right angle triangles I am fixing here the angle as theta, here also theta and here also theta. So the fixing angle theta, now I am just calling these as family of right angle triangles. What about I used a special word, that is family. Family means here if I take this one as x and this one as y, then this will comes as suppose 2x 2y, and this I am taking suppose 3x 3y. And next one, then automatically using Pythagoras formula you can observe this is nothing but under root of x square plus y square, and here also you can observe it is 2 root of x square plus y square, and here also you can observe it is 3 root of x square plus y square. Got my dear students? Now after this one I used family of right angle triangles. So family of right angle triangles, what is the meaning? The meaning is if I take here the ratio of any two sides, the ratio of these two sides. Now here if I take opposite side and hypotenuse under root of x square plus y square. Again here also I am taking opposite side divided by hypotenuse. Again here also I am taking opposite side divided by hypotenuse. So these are actually we got the ratio of corresponding sides. Everywhere I have used the same kind of sides. Here I took opposite side hypotenuse. Here I took opposite side hypotenuse. Here also I took opposite side hypotenuse. So that means the ratio of corresponding sides you observe here, that is same. Got the point? As all these are same, that's why we called it as family of right angle triangles. Now as all these are same, therefore this value, that is opposite side divided by hypotenuse, is a ratio, and this ratio is named as sin theta. This sin function is defined by or discovered by our mathematician Aryabhatta. So this one is sin theta, and here also I will write sin theta. See here everywhere you can observe all values are same. And now in the same way if you take adjacent side by hypotenuse, adjacent side by hypotenuse, so there also you can observe here cos theta equal to adjacent side divided by hypotenuse. Got the point? Now wherever you are taking all these theta, these are nothing but actually acute angle, and this theta here we define in between 0 and pi by 2. An acute angle, we observed all this. Now here while writing this, what is this theta actually? I said opposite. Opposite means not to me or not to you. Opposite means it is opposite to this side, and here also opposite to this side. Then only we write opposite side divided by, of course, hypotenuse, all of you know. And here I called as adjacent side. Adjacent side to whom it is? Adjacent side to this side. That is why we call it as adjacent side. So adjacent side divided by hypotenuse. And in the same way we define tan theta equal to opposite side divided by it is adjacent side. Opposite side divided by adjacent side, and this one is defined as tan theta. But while observing this tan theta, you can see here if I divide by hypotenuse, again divided by hypotenuse, now what is this value actually? The numerator you observe it is sin theta, and the denominator you observe it is cos theta. So this is nothing but sin theta divided by cos theta. So tan theta is not only opposite side by adjacent side, but you can write in terms of sin and cos also, that is sin theta divided by cos theta. So, these three are actually main functions: sine, S-I-N-E, cosine, tangent. Now, I will define here cosecant theta. Cosecant theta means it is nothing but just the reciprocal of sine. That means hypotenuse divided by opposite side, and that is why we call it as even 1 divided by sin theta. And next one is secant theta. This is hypotenuse divided by adjacent side. That is why it is 1 divided by cos theta also. And next one, it is tan theta, cot theta, it is equal to adjacent side divided by opposite side, and that is why it is again 1 divided by tan theta. So, these are main 6 trigonometric functions: sine, cos, tan, and next one cosecant, secant theta and cot theta. These are main 6 trigonometric functions basically we defined when theta is acute. So, dear students, after defining these 6 trigonometric functions, now let us define here Cartesian plane. I think all of you have very good knowledge about this Cartesian plane, which one is found by Descartes. Under his name, this is known as Cartesian plane. So, these are x axis, y axis, and this one is origin, it is x dash, and this one is here y dash. So, you know clearly this one is OXY plane where both x coordinate, y coordinate are positive. That means x and y both are here plus and plus. So, whenever if I want to mark a point 2, 3, suppose 2 is here and 3 if I take, then this is 2, 3. And if I want to mark a point 1 by root 2, 2, then this one is here 1 by root 2 suppose, and here I can take 2, and thereby this is the other point. So, like this here, whenever both x coordinate and y coordinate positive, that point will be always in first quadrant, and usually we denote it as Q1. Next, in second quadrant, x coordinate is negative, y coordinate is positive, and therefore, this one we call as suppose second quadrant. Here x coordinate negative, y coordinate positive. That means the point will be like this: minus 2, 3, minus 1, 3, minus 1 by 2, 3, minus root 2, 4. In that way, you can observe here points in second quadrant. Next, coming to third quadrant. In third quadrant, both x and y are negative. This we denote as Q3. Here we call both x coordinate, y coordinate negative, minus, minus. That means minus 1, minus 1, minus root 2, minus 1 by root 2, minus 3, minus 1 by 4. In that way we can find here all values where both x coordinate, y coordinate are negative. Now coming to fourth quadrant. In this one, in fourth quadrant, x coordinate positive whereas y coordinate is negative. So here if you observe, below x axis your y values are negative, above x axis our x values, here you can observe y values are positive. Below x axis these x values becoming as positive, here negative, and here also positive, negative. Now these are 4 quadrants, already you know about this, but just I am giving just a recalling. Now let us come to here again from trigonometry. I am taking here that Cartesian plane and just take a circle whose center is origin. So center of the circle is here origin, and next one that is O, and I am taking any point P of x comma y in first quadrant. P of x comma y first I have taken in first quadrant. Now join OP. If you join OP, then this angle you are taking in anti-clockwise direction. The angle is here in anti-clockwise direction. Moreover, you used a circle, so this angle usually we measure in terms of radians. Okay. So now here theta I am taking and next drop a perpendicular from P onto x axis. This is here M. And now you know very well about this one, the significance of this x comma y, this OM is x and this PM is y. And next OP value, it is radius of the circle, which is nothing but under root of x square plus y square. Got, my dear children? And now you observe the same definition, because this theta is an acute angle, therefore I am writing here sin theta is equal to y divided by r, and next cos theta is equal to x divided by r, and next tan theta equal to, we know it is y divided by x. So in this way I wrote these three values. Similarly, the connectivity from sin you can write cosec, from cos you can write secant, and from tan you can write cot also, which are the respective reciprocal values. Now let us come again from this diagram. I am taking here the line OP. If you observe, the line OP is like this, and I am just rotating this line OP in anti-clockwise direction. So in this way I am just rotating in anti-clockwise direction. Now suppose this is the position of the point P. So now you observe clearly, from first quadrant the same point entered into the second quadrant. Here both x and y are positive, whereas here x coordinate is negative, whereas y coordinate is positive. So if I drop a perpendicular here, now the same one we have taken, this is minus xy and this one is here r. Then in this quadrant, if I define again sin value, what is the effect? Y divided by r, no change at all, same positive value. Again if I define cos, minus x divided by r, that means here negative value you got. That means this is, suppose the second quadrant. In second quadrant what you got is sin value is positive you got, and next cosecant theta correspondingly it is positive, because exactly it is the reciprocal of the value. So no effect on y and r. And now if I start with cos theta, the effect started here, that means this value will now became minus x. Minus x means the value become here negative. In the same way secant theta, which is its reciprocal, negative, and next tan theta value, it is negative, because x contribution is here, that is why it is negative. Similarly cot theta also here negative. Now what is our observation? Theta need not be every time acute angle. The theta can be here even obtuse angle also. While finding these trigonometric functions, our impression is not only on acute angles, the same trigonometry you can do even for obtuse angles also. Then what is happening? Whenever theta obtuse, sin and cosecant, they are taking positive values. The meaning is, if I ask you sin of here 110 degrees, what is sin of 110 degrees? This value is positive, because 110 degrees is from 90 to how much here? 180. It is in between 90 to 180 degrees, therefore sin 110 degrees is positive. And if I start with sin 181 degrees, then I can't say this is in second quadrant. It is actually, the angle is now in third quadrant. So at present I am not talking about this one. So suppose if I start with cos 110 degrees. What is cos 110 degrees? Observe, this 110 is nothing but obtuse angle. Therefore cos 110 degrees is negative. Hence here this is negative. You can tell immediately about the symbol without finding the value, etc. And now what about tan of, suppose 91 degrees. Tan 91 degrees, again here you got a negative value. In this way you can find here, when theta is obtuse angle, these only sin, cosec are positive, the rest four trigonometric functions, they are taking negative values. Let us come again, the same line now rotated from here up to here like this. Now I am taking in this way, then this is the again drop a perpendicular, minus x is here and this one is minus y and this is as usual our r. Now while taking again in this one, you observe clearly this is minus x minus y. Our conditions from the first quadrant, you can observe very clearly. In first quadrant all trigonometric values, 6 terms, they are taking completely positive values. Now you are coming here to third quadrant, we rotated the line OP towards here in anti-clockwise direction. So this is your theta, anti-clockwise direction I am taking in this way, and now here these are the values. You observe what are the contributions of y, x, r. Sin y is here, r is here when this theta is acute. Now the same y you have to write how much? Minus y, opposite to theta. So minus y divided by r. That means this value sin theta in third quadrant we got how much here? Negative. And next one cos, you observe x is here, that x became now minus x. So cos also negative. Correspondingly the reciprocal value of sin, that is cosec, this value became negative. The reciprocal of cos, that is secant, that is also became now negative. Now let us observe tan theta. Observe here tan theta, this is y divided by x. Y divided by x minus y by minus x. Then minus minus get cancelled and thereby you got tan theta as positive. And hence here if you take the reciprocal, that is cot theta, now cot theta also you got here positive. Therefore what is our conclusion finally? The conclusion in third quadrant is only tan and cot are positive, the other 4 functions you are taking negative values. Let us come again to the fourth quadrant. In fourth quadrant again in the same way if you discuss, that means the complete this line OP I am rotating from here till like this in this way, like this we rotated, and that means the rotation you are taking anti-clockwise direction. So if I rotate in that way, again you can observe in fourth quadrant the results are what? What are these results? So if you observe x as it is positive only, but this y became negative and this one is our r. So what's happening? Sin theta, what is the contribution of y? Y is taking now negative value. So sin theta is minus y by r, which is negative. And next cos theta, here x and r, there is no y here, that's why it became as it is positive again. So x by r is positive. And again tan theta, what happened? Positive divided by negative divided by positive, hence it became again negative. So tan theta value you got how much here? Negative. Now the reciprocal of sin theta, that is cosec theta, it will become negative. The reciprocal of cos secant theta, it is again positive, whereas tan theta it is nothing but the negative. So cot theta also negative. So this is the brief discussion, the trigonometric functions in the 4 quadrants, and in 4 quadrants you observe, 4 quadrants means you have to take angle wise. So finally I am taking about again the same, these 4 quadrants. What about our conclusion on these 6 trigonometric functions quadrant wise? First quadrant Q1, here how are our angles? Angles are between 0 and pi by 2, and under these angles are all trigonometric functions. If you take, that is sine 10 degrees if I write, it is positive, cos 10 degrees it is positive, and it is tan of 83 degrees if you take, it is positive. In this way you can say all acute angles they will take positive values. So all trigonometric functions you can observe they are taking positive values when theta is acute. Now let us come to the second quadrant when the angle is from pi by 2 less than theta less than pi. So in this quadrant second quadrant, if you observe sine, cosecant, these are positive. Therefore, simply we say sine and cosecant, these are positive, rest are all here negative. So, do not misunderstand, C means actually here cosec and this one is sine, only these two are positive and the rest 4 other values they are negative. We observed already, that is if I take suppose tan 93 degrees, then this answer is clearly negative, and if I take suppose cosecant of 95 degrees, then this answer is positive, and if I take suppose secant of 35 degrees, then this value positive, because this 35 degrees that belongs to again first quadrant. And now come to third quadrant. In third quadrant, the angle is range is from pi less than theta less than 3 pi by 2. You are increasing slowly 90 90. Here 90, add again one more 90, again add one more 90. Here you observe tan and cot, only these values are positive, the rest all other values you observe negative. That means if I consider the values tan of, it is suppose given as 183 degrees, then this value is positive, and if I take suppose sine 181 degrees, then this value will become negative, because it is falling in third quadrant, which is in between 180 to 270 degrees. And if I take suppose cosecant of, it is 269 degrees, then also you observe it is less than 270, and hence this value also negative. Like this you can observe in third quadrant also. And next coming to fourth quadrant, here angles are in the range of 3 pi by 2 less than theta less than 2 pi. So, in this way these angles will come, and these are nothing but here cos and secant, only these two are positive, the rest are all negative. That means if I write here cos of 273 degrees, obviously it is positive, and next if I take here sine 271 degrees, then this value will become negative, because it is falling in fourth quadrant, where the range is from 270 degrees to here 360 degrees. So, now here these are all values. If you have any confusion, I will give in terms of even degrees also. This is 90 degrees, and here this one you can take 90 to 180 degrees, and this one you can take here 180 degrees to 270 degrees, and next this one you can take here 270 degrees to up to here 360 degrees. Right, dear students? Now you observe clearly all, and this one usually they call silver, tea, cups, but being all 4 faculty, I am telling here all 4 students talented in all competitive exams. You can remember in that way also, and we are so proud to say in this way. Now next one, after completion of this one, let us start again the next conditions of trigonometric functions. So we observed, if I take a right angle triangle, I am using the word as right angle triangle, and if I define this one as suppose x, this is y, and this one as r. R is nothing but under root of x square plus y square. Then we observed sin theta equal to how much, dear? It is y divided by r. Cos theta equal to how much we observed? It is x divided by r. Now sin square theta plus cos square theta is equal to, it is x square plus y square divided by r square. But what is our x square plus y square from the right angle triangle? It is again r square divided by r square, hence it is equal to 1. The meaning, you got sin square theta plus cos square theta equal to 1. Now this is known as identity. What is the meaning of identity? First of all, identity means for whatever values are defined to take these two functions, for all those values of theta, this answer is always true. That implies if I write sin square 10 degrees plus cos square 10 degrees, For this, no need of hurrying about what is sin 10, what is cos 10, etc. Just you observe these two angles are one and the same, and these are having square here, plus symbol here. So immediately your answer is 1. If I write suppose sin square 23 degrees plus cos square 25 degrees, can I say the answer is 1 here? No, obviously. Why so? Here the angles are different. So I can't write this answer as 1. So this answer you can write 1 provided the two angles are one and the same. So if I write this one as 23, then you will get the answer as 1. So in this way you can make use of this one. Then definitely you will get doubt. But then the name identity means for all values of theta. What are those values of theta? Here I am telling this is right angle triangle. But just now we observed through the circle, you observed theta can be acute, obtuse. Not only that, it can take values from 180 to 270 and it can take values from 270 to even 360 also. That is, you can observe here for only one rotation. Understand, if it starts from here, rotated like this, only one rotation. Now again the same line, if it starts rotation, second time, again rotation, third time, fourth time, like that, it can be n times also rotation is possible. Hence, theta not necessarily be only 0 to 90 or 90 to 180 etc. It will take all the real numbers. Therefore, this definition you use for every real number. So this is one of the important identities which we use in many other mathematical problems. From this one we can say sin square theta equal to 1 minus cos square theta, and then sin theta equal to under root of 1 minus cos square theta. But if I leave like this, it will be wrong. This is applicable only when theta is acute angle. Just now we have observed sin theta need not be positive every time. It can be negative, it can be positive also. That is why here I am using plus symbol, minus symbol, basing on theta value, acute, obtuse or any other real number. If it is just taking values only acute and obtuse, then you can take the value as positive. For other it is minus. That means third quadrant, fourth quadrant it is negative. So in this way sin theta we denote like this. In the same way, cos theta equal to plus or minus under root of 1 minus sin square theta. So these two you got from the identity sin square theta plus cos square theta equal to 1. And next one, whenever we have taken the circular measurement in this way, then you observe the point P, suppose it is falling exactly on x-axis. Here the point P, we said it is along the circle. That means there are cases where the point P can be on x-axis also. Then OP, P we defined as x comma y, and now this OP will become as R, because radius of the circle and this R is equal to how much here? X value. And therefore, whenever I write sin theta equal to y by R, then y value is here completely 0, because this point is x comma 0. So y is 0. Hence sin 0 we write as 0 divided by R, therefore it is 0. Whereas cos 0 if I write, it is equal to x and R both are same. So usually we write x by R, those are same, R by R, and hence it is equal to 1. And tan 0 if you observe, this is 0 divided by 1, whereas cot 0 if you observe 1 by 0, that leads to what here? Infinity. Cot 0 value, it leads to infinity because 1 divided by 0. And next one, suppose if I take cosecant 0, what about cosecant 0? This one also reciprocal of sin 0. Therefore, this value also 1 by 0, which leads to here infinity. And in the same way, if I write secant 0, the reciprocal of cos 1 divided by 1, therefore this value is here 1. And now we define here sin 0, cos 0, etc. What are undefined values you got? cot, and next one is cosecant. Cot and cosecant, here you got undefined values. Suppose if I come here, then this is P of 0 comma y and OP equal to R. And in this one, if you find here cos theta value equal to, how much is this one here? X value is 0, and hence here cos 90 degrees we say the value is 0. Sin 90 degrees if you take, the value is 1. And what about tan 90 degrees? Tan 90 degrees value is sin divided by cos, that means it is tending to how much? Infinity. So this is leading to here infinity. In that way, what about cot 90 degrees? This value will become now 0. And next one, other values also you can find here, secant 90 degrees, that is again leading to which one again? Infinity. And next one, cosecant 90 degrees if you find, this value is becoming 1. So in this way you can observe some values not defining for 0, for 90, in the same way for 180 degrees, for 270 degrees, for 360 degrees. What are those functions? You can say clearly tan theta, secant theta, these will define only when theta is not an odd multiple of pi by 2. Understand, 90 degrees, again here if you come across 270 degrees. So 90, 270 means these are odd multiples of 90 degrees. So for odd multiple of 90 degrees, these values are not defined. Understand, that means it will take every real number. Theta you can substitute any real number. Just now we observed the point P moves as long as on the circle, no worry at all. But whenever the point is coming exactly at this point and exactly at this point in the first rotation, and in second, third, fourth like that, then at these points you can observe these two values are not defined, but it will take all other values. So tan theta, secant theta, they will be defined for theta belongs to R, except which values it won't take? Odd multiples of pi by 2. Similarly, if you observe cot theta, cosecant theta, and these two values if you observe, cot value you observe here, you got undefined 0. So whenever the angle is 0. Similarly, if the line is coming in this way, then here also you can observe 180 degrees, cot value will become 0. Again next rotation cot 2 pi 0, again next cot 3 pi 0, cot 4 pi 0, like this it is coming. Therefore all values exist, whereas except here all real numbers, except here you can take n pi. So at these values, this cot and cosecant, they are not defined. Now why we are discussing about all these? So just now we have observed sin square theta plus cos square theta is equal to 1 for every real number theta. Whereas in the same way I can't say secant square theta minus tan square theta is also equal to 1 from the right angle triangle. That doesn't mean you can't say here for every real number theta belongs to R. So what is the condition? This holds good only when theta is belonging to all the real numbers except odd multiples of pi by 2. Whereas here cosecant square theta minus cot square theta equal to 1 for all real numbers except which one? Integral multiples of pi. N is integer, n is integer. This n value you observe here integer, and this n also integer. Whereas sin square theta plus cos square theta, it is equal to 1 for every real number theta. So these three are actually the essential identities which we are going to use in many kinds of future problems in mathematics. Now what about here secant square theta? 1 plus tan square theta, and secant theta plus or minus under root of 1 plus tan square theta. So we should write like this: secant theta equal to plus or minus under root of 1 plus tan square theta, because just now we have observed that is always secant theta need not be positive. For some values of theta it will become even negative also. In the same way, you can write here tan square theta. So, many students usually they commit mistake at this kind of identity. Very easily they say sin square theta is 1 minus cos square theta, cos square theta is 1 minus sin square theta, very easily they can say, whereas coming to these two a little bit confusion arises. Please try to avoid the confusion. And now here what about tan theta? It is plus or minus under root of not 1 minus secant square, but it is secant square theta minus 1. In the same way, cosecant square theta equal to 1 plus cot square theta. Therefore, cosecant theta equal to plus or minus under root of 1 plus cot square theta. Similarly, cot theta equal to plus or minus, again here we shouldn't commit any mistake just by writing 1 minus cosecant square, but it is nothing but how much? Cosecant square theta minus 1. So, like this, first we define three identities mainly under the conditions. The first one, sin square theta plus cos square theta is 1 for all theta belongs to R, whereas these two are under some restricted values. What are the restricted values? So, these one. So, under these only you can define them as exactly equal to 1. So, these are main three identities which we can define. So, dear students, till now we have observed what are trigonometric functions, that means ratios, how we have defined sin, cos, tan, etc. And next we observed for theta is not only for acute angle, these trigonometric functions defined for all different kinds of real numbers also we can define trigonometric functions. So, basing on that one, today we have discussed about all 6 trigonometric functions, not only right angle triangle, but three other quadrants also. Now, after that we have discussed about identities. Sin square theta plus cos square theta is 1, secant square theta minus tan square theta is 1, and cosecant square theta minus cot square theta equal to 1. These are all just basic values which we observed till now. Now, more identities also you can find. The more identities whenever you are finding, you can observe in future any problem if you are going to solve, in between 1 or 2 steps will come. At that time directly you can make use of this identity, so that your number of steps will become very less. Okay. So, dear students, hope you have understand whatever today we have discussed, and just be practice all these, and the next class we will discuss about trigonometric identities. More identities are there, you know very less, that is 3 identities you have seen, but we can have more identities where you can solve problems very easily for JEE Main and advanced level.